seen so far, whether on all the standard types 1, 2, 3, 4, right? In all the standard types, we have seen only P and Qs, X, Y, Z. So X, Y, Z are variables, dependent and independent variables, and P and Qs are only first order partial derivatives, right? But now we are going to discuss about how to solve higher order. Higher order means dou square z by dou x square or dou cube z by dou x cube. So that are higher order partial derivatives, right? So if a differential equation containing higher order partial derivatives, then how to solve that type of things, right? So we already discussed in the offline class also, right? So those who attended the offline classes knows better, right? So anyway, right? So not able to attend, right? So now you can see, right? But my advice is, if you are able to attend offline classes, try to attend the offline classes because it happened in all the 3 days, right? So it's good to attend the offline classes if it is possible, right? Okay. So now I'll share my screen. We straight away go to the topic, that is solving higher order partial differential equations. Right. Can you see my screen? Are all of you able to see my screen? Reply me. Can you see my screen?
Yes, sir.
Right. Okay. So we'll start. Right. Those who are attending now, right, they have to be in the class throughout. That is very, very important. Vijay Kumar,
Yes, sir.
what happened to you? Because in the beginning you are there, but at the end of the class you are not there when I'm taking attendance. Vijay Kumar, reply me. Vijay Kumar?
Sir. Yes, sir. Data slow. சொல்லுங்க சார். Yes, sir.
தம்பி கிளாஸ் ஆரம்பிச்சும் போது இருந்தேன், அதுக்கு பிறகு இல்லையே, அட்டண்டன்ஸ் இருக்கும்போது இல்லையேன்னு கேட்குறேன். அட்டண்டன்ஸ் இருக்கும்போது பேர் கூப்பிட்டேன்னு இல்லை. யூ ஆர் இன் தி கிளாஸ். நேற்று தான் தம்பி.
அது டேட்டா ஸ்லோவாக வருது சார். டேட்டா ஸ்லோவாக வருது, வெளில வந்துடுது சார். இன்னைக்கு கரெக்டாக இருந்தது, அப்புறம் சார் இயர் ஆஃப்டர்
சரியா? பார்த்துக்கோ.
ஓகே சார்.
சப்போஸ் ஏதாவது நெட்வொர்க் ப்ராப்ளம்னா வெளியில் வந்து என்ன பண்ணு, இது பண்ணு. ஏன்னா நீ கிளாஸில் இருந்த, பட் ஆனால் அட்டண்டன்ஸ் இருக்கும்போது உன்னால் அட்டண்டன்ஸ் கொடுக்க முடியல. ரைட்டா? அட்டண்டன்ஸ் இருக்கும்போது நீ எஸ்ஆர் சொன்னால் தான் என்ன பண்ண முடியும், இது பண்ண முடியும். சரியா? ஆடியோ ப்ராப்ளம்னா நான் ஆடியோ இது பண்ண முடியலன்னா சாட்லேயாவது எஸ்ஆர் உடனே என்ன பண்ணு, நான் கேட்கும்போது டைப் பண்ணு. சரியா? ஓகே, ரைட். Okay, right. So now, so what is higher order partial derivative? So here, okay, so you can see dou square z by x square and dou square by dou z square. All these things are all second order PDEs. Similarly here, all you have number 3. So all these things are third order PDEs, right? So in that manner, we can see in any general nth order partial differential equation. So this is an example for a nth order partial differential equations. And in that we are going to study about a particular type. So what is the particular type? Here we are going to study homogeneous linear partial differential equations of second order with constant coefficients. So here two things are important. One is homogeneous, another thing is constant coefficients. So constant coefficients means you can see in each and every term some coefficients are there. A0, A1, A2, A3, A4 are there. Why? Who joined now? Right? So you can see the coefficients A0, A1, A2, A3s are there. These are all, right, constant numbers. These are all constant numbers like this. That is -3, +2, here 1, here -1 is there, so minus is there, +4, +5, right? So with the derivatives, right, the coefficients are only constant, not the variables. You can't get x into or y into won't come, right? But in Lagrange's we see PP, where P is a function of x, y, z. But here all the coefficients are only constants, and right? So that it is constant coefficient. So then what is the homogeneous part? Homogeneous part means the left hand side part, right, where we can see call a differential equation as a homogeneous equation. So a linear partial differential equation in which all partial derivatives of the same order is called homogeneous linear partial differential equation. So this is called, they call it as homogeneous part. The left hand side they call it as homogeneous part. Why they call it as homogeneous part? Because there if you see, right, all the orders, right? So you can see here also you can see 3, 3, 3, 3, right? So whatever may be, whether it is dou x cube or dou y cube or dou x dou y square or dou x square dou y, all having third order in all terms. Similarly, here in this equation, you can see all having the second order, right? So that is called same order. So it is called as homogeneous differential equation because in which all partial derivatives are of the same order. So this is one partial derivative, dou square z by dou x square. And this is another one, dou square z by dou y square. But everything order is same. Order means what is the derivative? It is also a second derivative, here also a second derivative. So this is the meaning of homogeneous linear partial differential equation with constant coefficient. Linear I already gave some expansion, right? You try to remember, but anyway, when you solve this problem, all these things immaterial. So that I don't want to explain further. Only for understanding purpose I am telling. But when you solve the problem, we straight away try to, if we have a working procedure is there, and using the working procedure we can solve, right? So remember, homogeneous means order same, constant coefficient means the coefficients are should be in constant, right? But in examination all problems only given in this part, so no need to check. Whenever the problem given under this category, definitely all the questions will be only constant, and order also will be same only. Okay, up to this only I will allow, right? So now, right, there are some notations here they are using, right? So what are the notations, right? So those who already studied how to solve higher order differential equation in ordinary differential equation, this is partial. But if you this the same thing is there in ordinary differential equation, that is in the school, that is it in the school syllabus itself, right? So those who know that thing, they can easily understand this part. Whatever I'm going to see, it is the same thing. Whatever for the homogeneous differential equations, nth order homogeneous differential equation in ordinary differential equation, the same thing is there for the partial. So nth order ordinary differential equations already you have studied in the school. So if you are able to remember, it's easy. Okay. If it is not able to remember, no problem. Now I will teach you the same thing for the PDE. Try to understand. Then you can apply the same thing for the ODE also. What is the only difference between PDE and ODE? ODE is a special case of PDE, right? Because in PDE we have several variables. In ODE we have a one variable. So in a partial derivative, if you have only one variable, that become a ordinary differential equation. In a partial differential equation, we have n number of independent variables, right? Suppose we have only one independent variable, that partial differential equation become a ordinary differential equation, right? But you already studied ordinary differential equation, how to solve higher order through this method, right? Which we are going to discuss, right? If you remember, good. If you not remember, no problem. I will teach you in a very lighter manner, very easier manner, because this I already discussed in the offline class itself in a very simple manner, so you can easily understand. And examination point of view also, this is very, very important, right? So, right. So hereafter, I will not allow anybody to inside the class. So try to join the class within 5 minutes. 12:20, if another class is over means try to join by 12:25, right? Okay. So what is the notation they are using, right? So in our problem so far, whether even the order may be n, no problem, but we have only two independent variable x and y and one dependent variable z. Okay, that is same, right? Even the order may be same, dou square z or dou cube z or dou power 4 z, but whatever the may be, we have only two independent variables x and y and one dependent variable z. Now in this section, right, if we use the letter capital D to denote dou by dou x. Dou by dou x means differentiate with respect to x. If you put z here, you can also put z here. So if I write dz means dou z by dou x, right? So don't think here d is multiplying. D is not a multiplier. D is like a function. It's operated on the variable z. And what is that function? That function operated on the independent variable z, and it will be differentiate z with respect to x. Similarly, the another notation called as d dash. D dash. D dash is a representation of differentiating a dependent variable z with respect to y. With respect to y. Right? So d means differentiating with respect to x, d dash means differentiating with respect to y. Suppose if it is d square means differentiating z with respect to x two times. With respect to x two times. Similarly, d double dash of square, sorry, d double dash, right? D dash of here they put d dash, but this is r. It is not dash, it is r. Try to understand. So this is, suppose if I write d dash square, d dash square, not d double dash, d dash square. D dash square means differentiating y with two times. Differentiating the variable with respect to y two times. So here you can see dou square z by dou x square, right? So this term, right, can be written as d square z. So d square z means dou square z by dou x square, and this term can be written as, so here this also second derivative, but with respect to x one time, with respect to y other time. So I can write this as d dash of z. So what is d dash of z means? D dash is an operator operating on z, right? So d dash means you have to differentiate z with respect to y one time, and d means you have to differentiate z with respect to z another time. And finally, this term. So this term means you put it d, sorry, d dash square. Usually square comes here. D dash square. D dash square of z. D dash square of z means dou square z by dou y square. Similarly, d cube means here if you put d cube, that is dou cube z by dou x cube. Similarly, here if you put d dash cube, then it become dou cube z by dou y cube, right? Then here two times with respect to x, one time with respect to y means it is something like d square. D square means differentiating z with respect to x two times. D dash means differentiating z with respect to y one time. So this can be written as d square d dash of z. This. Similarly, this can be written as d times d dash square of z. So one thing you should remember, right? D represents differentiation with respect to x one time. D square means two times. D cube means three times, right? So that is the notation used throughout this unit. So that is mentioned here. So A naught is here. Dou uh, dou n of z by dou xn means n, you have to differentiate n times of z with respect to x. So they write d power n. You may ask, where is z, sir? Z is taken common outside here, like, because z is multiplied with all di, so that it taken out, right? And then this term is associated with this. What is this? Right? You have to do n times differentiation. In that n time differentiation, you have to do n minus 1 times with respect to x. So it is d power n minus 1. And 1 time with respect to y. So it is d dash. Similarly, d of n minus 2, d dash square. Right? So this should be square, not y. This should be square. Right? So this is the way, right? We can write this equation. And the right hand side will be a function of x and y. Right? So this is the general form of um, general form of writing an nth order linear homogeneous differential equation. Right. Now we are going to solve this. We are going to solve this. For that, there is a working procedure is there, right? For that, there is a working procedure is there. What is the working procedure? In the working procedure, right, there are two components. One is called as complementary function. Another one is called as particular integral, right? One they call it as CF, that is called complementary function. Another one thing is called as particular integral. So first we see what is the working procedure to find the complementary function. to find the complementary function, right? So that I will explain through an example, that only you can know, right? In complementary function, we don't bother about the right hand side, right? We take only the left hand side, and right hand side we assumed as 0. So that here, like, only in the latter part, that is when you find particular integral, that time only we are considering about the right hand side or of x comma y, right? So now I will explain both the working procedure with an example, so that you can understand. Straight away if I explain this, you can understand, but if it through an example, then you can easily understand, right? So first I will take one problem, right? Step by step I will explain you, right? So here I will solve at least 4 or 5 problems, then only you can understand. So I will do, right, important problems, right? So what are the problems I'm doing? It's examination point of view important only. At the same time, each and every one is different. From each and every problem you can understand certain concepts, right? So here you can see the first problem, right? Okay, either the first problem is visible to all of you? Reply me. Hmm? Find the general solution of, or of you able to see the first problem?
Yes, sir.
Somebody, right, right. So this is anonymity problem. In 2003 they asked same problem, right? So here they put 5d square minus 12d dash minus 9d square of z, d dash square of z equals to 0, right? So here right hand side is not at all there. So if right hand side is 0, just finding the complementary function is sufficient. If the right hand side some function will come, then only you have to find the particular integral, right? Okay, now what is the complementary function, right? The complementary function itself the solution of the given PDE. But how to find, right? There's a working procedure is there. There the procedure is already explained, but anyway I will explain through the example, then only you can easily understand, right? So first what you have to do now, you take an equation, and wherever d is there, you have to substitute d should be replaced by m. See, that is given here, right? So you put e5 in place of d, you put m square, minus 12 in place of d you put m, in place of d dash you have to put 1, right? Why we are putting, that procedure is there. So that is comes under the differential equations, theory of differential equations, but for you no problem, for you understanding how to solve the problem is more than sufficient, right? So you simply put 5m square minus 12, in place of d you put m, d dash is 1, then minus 9, d dash is 1, so d dash square also 1, so you simply put and equals to 0, right? And you should not put anything. This is called as accelerator equation. That accelerator equation can be written only from this derivative part, not from the variable. So only in this derivative part you take, and you have to write the accelerator equation like this by replacing d by m and d dash by 1. Now you have to solve this. So since this is a quadratic equation, you know EC formula minus b plus or minus square root of b square minus 4ac by 2a. Right? So this problem you already, formula you already know how to find the roots of the quadratic equation with variable x. But here in place of x, m is there. Right? So if you substitute here, a is 5, b is minus 12, c is 9, and if you substitute, you will get two roots. One is 3, another one is minus 3 by 5. Right? That is one form. Otherwise, whatever they put it in the book, right? Taking the common terms outside, and then also make it as a factor. So this is one factor, this is another factor, right? If m minus 3 is a factor, then m equals to 3 is a root. If 5m plus 3 equals 5m plus 3 is a factor, then 5m plus 3 can be written as 5m plus 3 equals to 0, can be written as um, m equals to minus 3 by 5, right? Taking the 3 that side become minus 3 and 5 comes down, so it become minus 3 by 5. So these are the two roots of this auxiliary equation. So it is called as auxiliary equation. how it gets? By putting d equals to m, d dash equals to 1, and you will get this two factors. From that, you will get these two roots. Once you get those two roots, what you have to do now? You have a standard procedure is there to write the general solution. Why they call it as general solution? Because it contains two arbitrary functions, phi1 and phi2. Right? Since the order of the differential equation is 2, right? And if you are able to write the general solution with two arbitrary functions. You try to remember when we form PDE in Unit 1, that is in first section, when we form PDE, we come across forming a PDE by eliminating arbitrary function. In that case, if the given equation having only one arbitrary function, you can able to find a first order PDE. If the given equation having two arbitrary functions, then you can associate it with a second order PDE, right? So in the same way, right, now you can do the same thing in the reverse manner, right? Now we have a differentiation, right, the differential equation, and if you're solving, when you're solving that, if you want a general solution, you know always general solution having arbitrary functions, complete solution having arbitrary constant, general solution having arbitrary functions, right? Since the order of the differential equation is 2, right, your final or general solution must have the equal number of arbitrary functions, so that phi1 and phi2. Then you may ask how it comes, y minus 3 by 5, y plus 3x. This is nothing but y, the first root. What is the first root? Minus 3 by 5. So they put y minus 3 by 5 into x. Then y plus the second root is 3x. So here the working procedure is, whenever if you have a root m1 and m2, whenever if you have a roots like m1 and m2, right? Then the procedure to write the equation is phi1 y plus m1. M1 is the first root. First root is minus 3 by 5. So minus 3 by 5 y plus mx, where m is the root, right? That only we written here, y minus 3 by 5. Then plus phi 2 y plus m2. M2 is 3 here. So it is 3x. That only written here. Right? So procedure is y plus mx. Right? If m1 and m2 are the roots, then y plus m1x and y plus m2x. That only written in the procedure also. That one is written in the procedure also. You can see the procedure. Right? The working procedure says if the roots are different, like m1, m2, m3, then the complementary function can be written as phi1 y plus m1x. So here m1 is nothing but minus 3 by 5. Then phi2 y plus m2x. M2 is nothing but 3. Right? Since we have only two roots, we have only two terms. Suppose if you have n roots, then we have n terms in the complementary function. Right? So now we found the complementary function of the PDE. Since the PDE has the right hand side 0, what are the complementary function? Itself the general solution. Suppose if the right hand side is non-zero, then you have to find a particular integral, and then complementary function plus particular integral becomes solution. But here there is no particular integral, so straight away the complementary function is equals to your solution, right? So originally z, the solution can be written as complementary function CF value plus particular integral value. So particular integral value will come only if the right hand side is non-zero. If the right hand side is 0, there is no particular integral, then straight away your z is equals to complementary function. So that only they put z equals to phi1 3 minus x and phi2 y plus 3x. So this is called a solution of the, particularly general solution of the given PDE, pi d square minus 12 d dash minus 9 d dash of square of z equals to 0 is equals to 0. So here just remember what you have to do. First you have to write this part, don't take z. only this part, and we replace d by m and d dash by 1. Then once you get the accelerator equation like this, right, you can use your common sense and find the roots of the equation. Once you find the roots of the equation, you can write the general solution as z is equals to phi 1 y of this root. This root is minus 3 by 5 x plus phi 2 y of this root is m, that is 3. Second root is m2, that is 3. So they put 3x, right? So y minus 3 by 5x or y plus 3x with the arbitrary functions phi 1 and phi 2 is called the general solution of the given PDE. In the same way, we can solve other problems also. Only thing is the number of roots different, right? So here you have only two roots, minus 3 by 5 and 3. And in some problems, the number of roots are different. And in some other problem, the roots may be complex also. The roots may be complex also, right? So when you see this particular problem, we have a third degree, third order PDE. So again, if they put d equals to m and d dash equals to 1, and they write the equation, then you can use some idea, right? Because you already know how to solve equations with second degree or third degree, right? Then use some common sense, or there are some methods are there to find the roots of the equation. Using that, you have to find the roots of the equation, or you can use the same method whatever you are putting here, taking the factor of the equation, and then you try to find the roots are minus 1 and plus 1, minus 1 and plus 1. How it comes? M plus 1 is a factor, so m equals to minus 1 is a root. Similarly, m square minus 1 is a factor, that is m square minus 1 is equals to a factor. From this, we'll get m square is equals to 1, and m is equals to plus or minus 1. Right? So here we have one value of minus 1 already there, and here you are getting 1 plus 1, another minus 1. So you get two minus 1s, this minus 1 goes here, minus 1, and this plus 1 goes here, right? So you have 2 minus 1 and 1 plus 1s, 2 minus 1 and 1 plus 1s, right? So here what is the change here? You have three roots because the given equation is a third order one, so you have three roots. But first two roots are repeating. See, minus 1 and minus 1. In that case, what you have to do, no, right? You put phi 1 of y, this minus 1 minus x, then phi 2 of y minus x, and phi 3 of y plus x. Plus x means because it is plus 1. But if you are able to write the same root in the second time, you have to multiply x with your arbitrary function. You have to multiply x with the arbitrary function. Suppose if you have minus 1 repeats 3 times, suppose the minus 1 repeat 3 times, right? Then what you have to do now? First time you have to write as it is, y minus x. Second time you have to write y phi 2. Don't write phi 1, phi 2 y minus x. But since you are writing the same y minus x, that is minus 1 root second time, you have to multiply with x. Suppose the minus 1 root repeats 3 times, not only minus 1, any root repeat 3 times, third time, then you have to multiply x square with phi of y minus x. And here also you have to put 3. Here also you have to put 3. So phi 1 y minus x into phi 2 y minus x, and x square phi 3 y minus x. So why you put x square? Because the root minus 1 repeats 3 times, right? So in this manner you can write, if the roots are different, very simple, you can write as it is. If the roots repeated, then if a particular repeats 2 times, then you have to first you write as it is. Second time you have to multiply the same y minus x. Here same y minus x, same as will come, but there you have to multiply x with the arbitrary function phi 2. If the same root repeats third time, then you have to multiply x square with phi 3. This is true for n number of times. This is true for n number of times. Then you may ask, suppose the roots are complex, then what will happen, right? Suppose you are getting some equation like this, m square uh, m square plus 1 is equals to 0. Right? So in this case, m square is equals to minus 1. In that case, m is equals to plus or minus I. Right? So here plus I is a root and minus I is a root. So both plus and minus I are complex numbers, complex roots, right? And it always occur in pair. Occur in pair means suppose 1 plus I is a root, then definitely 1 minus I is also a root of that particular equation. Right? In that case, what we have to do? In that case, very simple. Just like what you write, how you put 1 and minus 1, in the same way you put plus I if the root is I, and you put minus I if the other root is minus, right? So wherever that just like how you are putting the real roots, same way you have to put the complex roots also, right? So here for example, I'm putting plus I minus I. Sometimes it may be 1 plus I or 1 minus 5, but whatever may be, both are conjugate to each other, right? So so they occur in pair. So in that case, you just put that number, right, before here, right, before here. 1 means 1, I means I plus 2 means I plus 2, whatever may be, right? That you have to put before as the coefficient of x, as the coefficient of x. So this is or there in the left hand side part. So far we discussed the problems where the right hand side is 0. Right hand side is 0. So if the left hand side means very simple, you have to put d equals to m and d dash is equals to 1, and you have to solve this equation and you will get the roots. Once you get the roots, directly you can write the a general solution. That is originally it is a complementary function, but here there is no particular integral. So the complementary function itself the general solution. See, the given problem has a third order one. It is a d cube, and you have three arbitrary functions in the solution. So that it is a nice one, right? So suppose, right, and you are getting the general solution of the problem itself. General solution of the problem itself, because order and the number of arbitrary functions same. Order also 3, number of arbitrary functions also 3, so that it will be a general solution of the given PDE. So this is general solution of the given PDE. Right. Do you have any doubt on this? Because hereafter we are going to the right hand side part from example 4 onwards. There the working procedure is little bit different. Have you understood?
Yes, sir.
Okay. So in between I will take the attendance also now, right? But class will continue after attendance also, right? So I just call your number. If you know the number, you tell the number. Other if you don't know the number, at least you tell the name, right? So 1 to 10, anybody there? 1 to
10%, sir.
10. 1.
1%, sir.
Okay, Anit is there. Okay.
10%, sir.
6%, sir.
10. 6 is there.
6%, sir.
Sir, 10%,
Okay,
sir.
6 and
18,
10.
sir.
Sayed is
7,
there,
sir.
and then Aman Kumar is there. Okay.
7,
Then
sir.
Yes, sir.
Hari Govind 7. Okay, Hari Govind also there. So 1 minute I stop sharing, then only I can make it as a big one. Wait. Okay, now I can see all of you. Right. So 1, 6, 7, 10. 11 to 20. 11 to 20. Kumar Yuvaraj.
12, sir.
12. Anand Kumar is there.
Yes.
What happened to Kumar Maharaj? No reply. 20. Mohammad Afsar. 11 to 20, I have only one reply, that is Anand Kumar. Right. No reply from Kumar Yuvaraj, no reply from Mohammad Afsar. So I am not able to mark. So 21 to 30.
21 present, sir.
21 Danush present.
28, sir.
28 Surya
Yes, sir.
B present. Anybody there from 21 to 30? Anybody is there from 21 to 30? Nobody there. Okay, then 31 to 40. 31 to 40. 31 to 40 also nobody there. Then 41 to 50.
Sir, 46, sir. G. Vijay Kumar.
G. Vijay Kumar. Okay.
46.
Okay, then.
42. 42.
Okay, for Shilpi and Jayaprakash. Okay, Shilpi Quran is there. And then Jayaprakash. Okay. Okay, three people. Vijay Kumar, Shilpi, Jayaprakash. Then, what about Shiva Prakash? Are you
52,
there?
sir.
Shiva
52, sir.
Prakash.
Yes, sir. Siva Prakash, sir.
Shiva Prakash C. Right?
Yes, sir. 52, sir.
தம்பி 52ன்றது நீ பழைய நம்பரு. இப்போ அது எங்க நீ ஏ செக்ஷன்ல இருந்தபோது இந்த நம்பர் அது?
B section, sir.
ஆ? இ செக்ஷனா?
B section இருந்த பழைய நம்பர் சார் அது.
பழைய நம்பர் பி செக்ஷன்ல இருந்த பழைய நம்பரா?
எஸ் சார்.
சிவபிரகாஷ் ஆனா சிவபிரகாஷ் சி தானே?
எஸ் சார். நம்பர் சார்?
இதுல 36 போட்டுருக்காங்க 36.
36. Okay, sir.
ரைட்டா? Okay. Anybody there not giving the attendance?
Sir, what's my roll number, sir?
தம்பி ஜெய்சன். ஜெய்சன் தம்பி உனக்கு 48 போட்டிருந்தாங்க, இப்போ 45 போட்டிருக்காங்க. ஏன்னா சில தடவை நடுவில் டிலீட் ஆயிருக்கு, நடுவில் அதனால நேம்ல வச்சுக்கோ, சரியா? ஜெய்சன். எனக்கு நேம் சொன்னா கூட போதும், ஐ வில் கோ இட், நோ ப்ராப்ளம், ரைட்? பிகாஸ் நம்பர்ஸ் ஆர் மூவிங் அப் அண்ட் டவுன். ஸோ நவ் ரைட், ஸோ ஐ ஹவ் 1 2 3 4 5 6 7 8 9 10 11 12 people are there. What about Kumar Yuvaraj and Mohammad Absar? Kumar Maharaj, no reply. Mohammad Absar, no reply. If you have any audio problem, at least you type. Yes, sir. Both Kumar Yuvaraj and Absar. Now, immediately. Kumar Yuvaraj, if you have any audio problem, you can type at least in the chat. Okay. Right? So, whenever if I ask your name, right, if you are able to reply, immediately you have to put yes, sir, in the right chat box. Okay, then what about Mohammad Absar? No reply from Mohammad Absar. Right? See, apart from your number, don't put it some other thing. Aman Kumar? Aman Kumar.
Yes, sir.
Then why are you putting when will the hostel open? When I take the class, you have to attend the class.
Yeah, okay,
if you have any doubt, you can ask me at the end of the class. And this is related to hostel open. There you have to ask only your department staff member and your HOD. Right? Because I am a maths teacher, I don't know anything about your department and your department hostel opening, all these things. Right? And even if you ask, you can ask, no problem. If you have any doubt, you can ask, no problem. But in between the class, you should not do like this. Right? So in between the class, you have to only focus on the class, not simply typing another thing. Right? Okay, so class will go on. Right? Stay on. So now again, I share my screen and I'll continue. So Mohammad Absar is not replying, so I can't. I put one. Why you now? Where are you gone, Mohammad Absar?
Sir, mic problem, sir.
Mic problem na adan sonna naane idhila yes sir type pannune.
Net slow-ஆ இருக்கு சார்.
மைக் ப்ராப்ளமாக இருந்து கேட்கலன்னா டைப் பேச முடியலன்னா அட்டண்டன்ஸ் எடுத்த அதே நேரத்தில் எஸ் சார் மைக் புட் மைக் ப்ராப்ளம் புட் எஸ் சார், நோ ப்ராப்ளம்.
வெளில போயிட்டு உள்ள வந்தேன் சார், அதான் சொல்லுங்க.
Right, but anyway, if there any problem, you have to join immediately. Otherwise, you try, at least you have to put, when I take attendance, you can put message. Other times, I can't able to see. Right, when I take attendance, at that time, at least if you are not able to reply, you put immediately in the attendance, yes sir, when I ask oral attendance. Right? Okay, this day, okay, right. Okay, no problem, Mohammed. Right? I'll mark your present today, but this same thing should not happen again for anyone. Right? Okay. So now I continue my class. Right? I hope you can see my screen. Right? So now we can see the higher order partial differential equations with the right hand side non-zero, right? So if the right hand side is 0, you have to only find the complementary function that itself the solution. So you can see a CF. CF is called a complementary function, right? But now we have the right hand side. It's also there. Further, there's a separate procedure is there, right? And then using that procedure, you have to find the particular integral also. Then the final solution can be written as z is complementary function plus particular integral. That is phi of whatever the written here, phi of y plus x into phi of y plus x, right? That term plus whatever the term you are found in pi, particular integral. Pi is called as particular integral. CF means complementary function, right? That you have written here. Then the sum will be the general solution of the given PDE. But how to find, right? That we will see now for the next 10 to 15 minutes, right? So you already know, in order to find the complementary function, we have to assume the right hand side as 0. So assume right hand side as 0. First, try to find complementary function. For that, you have to put d equals to m and d dash equals to 1, and m square minus 2m plus 1 equals to 0. From this, you can easily write this as a minus b the whole square formula. So that is m minus 1 the whole square, and you can write m equals to plus 1. So 1 repeats 2 times. So you write phi 1 y plus x, and phi 2 again you are writing the same y plus x again because the roots repeats. So you have to multiply with x, right? Suppose if this repeats 3 times, suppose, then what you have to do? You have to put x square, and then you put phi 3, and then you have to write y plus x, and then you have to write y plus x, right? That is the, but here we have only 2 roots, so we write only 2 times. Then how to find the particular integral, right? So right hand side, here you have an exponential function. So there is a separate procedure for exponential function. In some problems, instead of exponential function, trigonometric function, that is sine of x plus y will come, or x plus 2y will come, or cos of x plus 2y will come. Similarly, in some problems, in right hand side, it may be x square plus y square. That is algebraic type of function. Algebraic means our ordinary polynomials, x square plus y square, right? So, but each and every one, every particular integral type has a separate working procedure, right? I will teach you what is the working procedure for the right hand side if it is in exponential form, right? So you look at here, it is in e power x plus 2y. So it is something like e power ax plus by format, ax plus by format, right? Where a is the coefficient of x, where b is the coefficient of y. So here coefficient of x is 1, you can see. Here the coefficient of x is 1 and coefficient of y is 2. That is a is 1 and b is 2. Right? A is 1, b is 2. Right? Now what you have to do now? Simply you have to substitute, right, in the denominator. Right? You write whatever the equation here. You straight away write it. Right? Sometimes you have to write in factor form, sometimes you can straight away write. So here in this problem you can straight away write, right, the equation, and then in place of d you have to substitute 1. Why? Because this is e power ax plus by format, ax plus by format, where a is nothing but the coefficient of x and b is nothing but the coefficient of y. So whatever the coefficient of x, that should be put in place of t. Then whatever coefficient of y, that is b, that should be placed in place of d dash. So here in place of d, you have to substitute 1, because here e power x, so coefficient of x is 1. In place of d dash, you have to substitute 2. Why? Because the coefficient of y is 2, right? So very simple. If you substitute d equals to 1 and d dash equals to 2, then you will get a nice number in the denominator, right? That is 4. Here also you will get 4, 1. So 1 minus 4 plus 4. So plus 4 minus 4 cancel out. You will get 1 nicely. So 8 by 1 is 8. E power x plus 2y. So this is the particular integral. So what is the working procedure for exponential function? Now we'll go there. Now you can easily understand. So the working procedure for exponential function is, now you can see the general format. Right? So working procedure for exponential function is, if the r of x comma y, that is the right hand side, is e power ax plus by. If r of x comma y is e power ax plus by, then right? In the denominator, wherever d is there, you have to replace d by a, and wherever d dash is there, you have to replace it by b. So what is the a and b? A and b are nothing but coefficient of x and coefficient of y. So directly in the denominator, right, you have to write that whatever given equation given in the question, the same thing you have to write here, but don't write z, right? Only d dash you write here, the same equation, and in that equation you have to put, in place of d, you put the a value. In place of d dash, you have to put b value. You have to put b value, right? And then if whatever things comes, you have to write, and then you have to add that with your complementary function. Add that with your complementary function. Then the total thing, complementary function plus particular integral, become the solution. Become the solution, right? So this is the working procedure for exponential function. This is the working procedure for exponential function, right? The same thing you can follow, right? 1 minute. Right? So same thing you can follow for this type of hyperbolic functions also, because the hyperbolic functions can be written in terms of exponential functions, right? So here a simple example, right? Cos hyperbolic. Don't confuse this with trigonometric function. If it is cos 3x plus 4y, then the working procedure is different. But here it is cos hyperbolic 3x plus 4y. So you know cos hyperbolic x, cos hyperbolic x, writing cos hyperbolic x can be written as e power x. I'm writing its power, right? E power x plus e power minus x divided by 2. So I write x here. E power x plus e power minus x divided by 2. So this is the relation between cos with exponential. So here in place of x, you have 3x plus 4y. So here we can write this as e power 3x plus 4y plus e power minus x. Minus x minus of 3x plus 4y divided by 2. Divided by 2. Right? So then now we have two particular integrals. Now we have two particular integrals. 1 minute. Right? One is e power 3x plus 4y. Another one is e power minus of 3x plus 4y. Right? So two things are there. Now what you have to do now, for this problem you have to find the particular integral 1 and then particular integral 2, because it is in addition. If it is in product, then the thing is different. Since it is addition, you have to find the particular integral 1 and particular integral 2, and then your final solution will be complementary function plus particular integral 1 and particular integral 2, right? So complementary function very simple. You have to write the equation and you have to find the roots. So roots are 1 and 2. So y plus first root 1, so 1x plus 5 2, y plus second root is 2, so 2x. So complementary function is very simple. Then particular integral. So when you sign particular integral, again you write the original equation. The original equation is d square minus d dash plus 2d dash square. And then wherever d is there, you have to substitute the coefficient of x. Here what is coefficient of x? Here the coefficient of x is 3. Coefficient of y is 4. So you have to write d as 3 and d dash as 4. And you have to substitute, then you get a nice number in the denominator, and we call this as particular integral 1. Then what is particular integral 2? Particular integral 2 is e power minus of this thing, that is e power x plus e power minus x. So here 3x becomes minus 3x, 4y becomes minus 4y. So in place of d, you have to substitute minus 3. In place of d dash, you have to substitute minus 4. Then you will get a nice number in the denominator, and that is particular integral 2. Then your final solution will be your complementary function plus your particular integral 1, this equation, plus your particular integral 2, this equation. Since phi is common, they are taken out. Right? So in this manner, right, you can find the solution of the higher order PDE with the right hand side is an exponential function. With the right hand side is an exponential function. Right? So in the similar way, the right hand side trigonometric function is there. The right hand side that algebraic function, that is x square y square, is also there, right? But we discussed these two things in the offline classes itself, because there we have a extended time, right? But here we have a limited time. Okay, but still we'll try to make it. So if possible, I will take some extra hours, right? Extra times, right, in the future, right? But anyway, still now you are in the examinations, I think, right? Still examinations are going on, so I don't want to take disturb you during the examination, right? So I stop here. So I will continue the rest of the things in the next class. So now, right, all of you type your name and number as the out attendance in the chat box, and then